Good evening. What are you doing today? Okay, so today I'm planning to discuss 4 different topics. One topic is when you have some sort of equation and you want to write that equation, piecewise equation, and you want to draw a function which is given by that equation. So this is one type of problems that you have on tests generally, very popular one. I'm giving you some sort of piecewise thing and you need to plot it somehow. Now, this thing could be given, of course, as a one-liner which is involving all kind of step functions. The other one is the inverse problem. When something is given as a plot and you need to write it as a function of those step functions, which is basically a piecewise function which you need to write as a one-liner, a single line of equation. And you can do that with those step functions. So how you approach the problem and how you deal with that kind of problems, that's what I want to start discussing. Now, another question that we will be dealing with is how you compute power and energy. More or less, it's just putting some numbers into integral and then the rest is just calculus course. It's not related to anything new that you don't know. Now, if you have troubles computing integrals, again, you have a big table of integrals where almost all of the functions that you will ever need in the course you have in that table. And then the most tricky part is computational periodicity of functions. How you compute periodicity of some given trigonometric or not trigonometric function. Something periodic, you need to find period, how you compute that period, how you prove that this is actual period of the function. All of those questions are a little bit tricky because frankly you need to do a lot of guesswork there. So you need some sort of experience with just guessing the right period and then trying to prove that this was the actual period. And not always it's that simple. So for that you have all kinds of rules which are helping you to guess, but nothing like algorithm available for computer which will tell you, here, this function is periodic, or this function is not periodic. No computation will help you with that. You just need to guess and then to prove it. Okay, so let's start with something very simple, and those are step functions. So step function is also called Heaviside function. So Oliver Heaviside used those functions in electrical engineering about 100 years ago. And this function is very convenient because we will be using that function to write any piecewise functions. It's very convenient for that purpose, and then it's very easy to apply integrals to that function because it's just defined like that. It's 0, then t less than 0, and 1 otherwise. This is how this function is defined. It looks like that. Let's take another color. So it goes 0, then it jumps to 1, and then it continues as 1. This one is u of t, this one is t. Now, what we want to know about the functions, how to shift it left or right with different coefficients, how to flip that thing left and right, and so on. Those all very convenient for us. So this is related to transforms of the functions. If you want, let's say, that kind of function. What is that? Your negativity. This is your negativity. How about
U t minus a.
u of t minus a. Well, this one goes like that to 1 t plus. This one is plus a. Now, why all of those things are important is because we want that kind of function. It will look like that. This function, sometimes called pulse function, sometimes index function. You have all kind of names for that kind of function. So it's rectangular pulse between A and B. So how can you write that? Using u function, step function.
T minus a minus.
So saying this is u t minus a
Plus,
plus.
do you have to split it up and like define it on a certain domain and then up and away?
So you can write that as some function between two step functions.
Right.
So you have
U t
u
minus
of
a and
t
the other would be.
minus b, which is starting from here, and ut minus a. So what I need to put between them? Hmm?
Union?
Union? No, it's much simpler than union.
Plus.
No. Look, you have, let's draw each one of them separately. Okay, so it will go like that. So this is A, this is B, right? This one is U t minus A, and this one
Minus u t.
U t minus B. And I want that thing.
You just subtract u t minus b.
Just put in minus B. As simple as that. Why? Because you're taking that red one. So it will be 0 minus 0, 0 minus 0, 0, point by point, right? Until you get here. So here it will be 1 minus 0. So it's 1. 1 minus 0, 1 minus 0, 1 minus 0 until you get here. And here it gets 1 minus 1, 1 minus 1, and so on, which is again 0. So you get something like that. Okay, so here it's 0 minus 0, here it's 1 minus 0, and here it's 1 minus 1. On all of that interval to the infinity. Which means it leaves us these ones only in that interval. Now, clearly you can define it in a different way. For example, you can do, let's say, u of t minus a times u of minus t plus b. This also will work, but this is not very convenient. Right, so you're taking that function, the second function is flipped left, kind of to the left, right? And then you multiply those two. So it will be 1 only in that interval for both functions. So here, that function will be 0, here, that function will be 0, and the multiplication will be 1 only in that interval. But this is not very convenient. This one is much more convenient for other computations. Okay, for simplifications, algebra, and so on. But this is also correct. You can write that pulse with that function. So you have multiple ways to describe those functions. Okay, so why is it so useful to use that thing? Because if you have piecewise function, you would like to take each piece where you can write your function analytically first kind of single equation, and to multiply by z within that specific interval you want. Now, you're adding another one here for another interval, right? Analytically multiplying by z pulse here. And so on. So you're dividing basically all of the t axis into intervals. And you're multiplying each interval by that one function, which is kind of index function. It shows you, it gets you back your function in that interval and zero otherwise. Now, if you're adding all of them, all of those intervals, what you get back is your original piecewise function. This is the overall idea. So let's write the steps that we need. Okay, let's take some example. Let's say you have something like that. This is t, this is x of t, and it looks like that. So here you have, for example, e or minus t, it gets to 1, of course. And here you have linear segment between minus 2, 0, and 0 minus 2. Okay? You want to write the piecewise function in standard way using step functions. So first thing that you need to do is to define that function. Do you know how to define that function? How you write equation of that line?
Yes.
So the general formula is very easy. Something like that. Sometimes you write it z1 divided by z1 equals that ratio, which is basically slope. Right? So slope equals to any pair of points, including all of those points here. Pretty easy to remember. Okay, so let's compute. Can you guess what that thing will be? What will be the slope? So you have 2 points, minus 2, 0, and 0, minus 2. Right? So this is your x1, y1, x2, y2. So let's put it in y minus y1, which is 0, y2, which is minus 2, minus y1, minus 0, divided by x2, which is 0, minus 2, which is plus 2. X minus x1 is minus 2, so it's plus 2, right? So this one is minus 1, this is the slope, this is the slope of that line. This is 0, so y equals minus x minus 2. This is the equation of that line. So it's actually should not be y and x, in our case it's x and t, so x equals minus t minus 2. This is the equation of the line. Any questions so far? So at that interval, this is what you have. Now, sanity check. How do you know that this is correct? Because I might make some mistakes on the way. You just put in that point and that point and checking that both points are satisfying the equation. If you put in, for example, t equals minus 2, so it's minus 2 plus, like minus 2 plus 2, it's 0, so it works. T equals 0, so it's 0 minus 2, gives you y2, so it works. Okay, just check. The calculation was right. Okay, so now let's write the steps. Step number 1. Divide into intervals of t such that in each interval the signal will have a single formula description. In our case, I want to divide that entire function into intervals, where in each interval it will have just single formula. That's it. In our case, it will be that interval from minus infinity to minus 2, then from minus 2 to 0, and then from 0 to infinity. But you might have, depends on the function, might have multiple intervals. So those are the intervals. In our case, this is what we will have from minus infinity to minus 2, then from minus 2 to 0, and then from 0 to infinity. Those are the intervals. Step number 2, for each interval, write a combination of step functions. So those step functions should be 1 inside of the interval you're talking about and 0 outside. So you need something like that. You're using the index function, pulse function. So, how you write that thing?
Why you need yours in those
So you need from minus infinity to that point. You don't have any pulse. You need something of that kind, but shifted.
two? Are we running a piece like something like that?
So you can write it like that. First of all, you invert, and that thing is minus t. You can left, right, and then shifting to the left. How you shift that function to the left? Plus or minus 2.
What? Plus.
It's actually minus. How do you know that this is minus?
Here is the minus 2. Here's reverse.
How you check that? I mean, it's easy to make mistake. So you say plus 2 because plus kind of moving to the left is plus, right? And moving to the right is minus. But when you have minus here, it's kind of the opposite logic. But how, without thinking about that, how do you know that this one is correct one? How you check easily?
The x value. Put in minus
Where you put in 4.
So this function should change
2.
at which point?
Minus 2.
At point minus 2. If you put in here minus 2 instead of t, what do you get?
0.
You get step of 0. And this is exactly the changing point here, right? It's like u of 0. And this is kind of point where you want the change. If you put here plus 2, then you'll get u of 4. U of 4 is just 1, somewhere here, right? Nothing happens here. Nothing interesting. So from that you know that you need minus and not plus. So always check yourself. When you're not really sure how to do that, just check the 0 point, like where this equation equals to 0. And this is change point. Okay, so this is the first interval. How about the second interval? So it's from -2 to 0. You get ut plus 2 minus u of t, the second interval, from -2 to 0. And the third one from 0 to infinity, which is just u of t. Right, so those are index functions, yes.
Why do we do the minus t instead of just doing it t plus 2? Is it because of the direction?
Because if you need something which will look like that, right? That's what you need. If you'll do t plus 2, it will look that way, and not that way. Now, in that case, it doesn't matter, because you just multiply that by 0 anyway.
Okay.
So that function will just be removed later. But in case you have something here, some function,
Okay.
in that part,
If it was a
you will need
one.
to multiply by something like that.
So if it was a 1 and then drop down,
Yes.
we would have to have minus t.
So you need that kind of index, where it's 1 until it gets to -2, and then it drops to 0. And then you divide that with second function, which will look like that. And then third function, which should be 0 up to here, and then go up. This is how you divide the entire time interval into multiple functions of that kind or that kind. Okay. Now the other thing that's left to do is just to multiply all of those by those functions and to add them together. That's it. So this is the last step, how you convert it into actual formula. Multiply. So we're multiplying by the index function in each interval and adding them all together. So in our case, this is what you'll have. You'll have u of minus t minus 2 times what? What is the analytic function before minus 2?
Why was 0?
0. It's always 0. Plus second one will be this one, u t plus 2 minus u t times what?
Minus t.
Minus t minus 2. And plus ut times what? E to the power of negative 2. That's it. This is x of t. Now you can simplify it a little bit, taking just ut together with this one, if you want, but you can make it as is. So this one equals 0. Just to simplify it, it will be minus u t plus 2 times t plus 2 plus u of t times exponent plus t plus 2. That's it. This is just algebra. Is it clear how I got to that one? I just took minus u times minus t minus u times minus 2, it will be u times t plus 2. Right, so this minus will cancel those two. And then I have u of t, which is common here, times e to the power minus t. And then I have this one times this one, which is that one. Here I have minus.
No, that's what I was wondering, that was a negative.
It's negative here. Because we have negative here. So this minus comes here. And the first one is just 0. Any questions? Okay? Another example. Now you have x of t given by t, q, t plus 3 minus t squared t plus t minus 2 times u t minus 3. And you want to plot. You want to plot that kind of function. How do you start to solve that kind of problem? The easiest way to start is basically to plot all the step functions near the equation first. We're going to see what happens. How this thing looks like, this thing looks like, how this thing looks like. But this one is easy. It's standard step function. Now, second one is also easy, just shift it back. T minus 3. Okay. And third one is shift it right. 3. Okay, now for each one of those terms, they will be turned on or turned off based on multiplication by those functions. Now we need to check what happens when we're going from minus infinity with t to plus infinity. Which one of them will be turned on and at which points. So step number one is always to write all of the critical points first. So what are the critical points in that case?
-3.
Critical points. By critical point, I mean that they are changing their behavior somehow. Okay, so critical points here, -3, 0, and 3. So those are the only points where something will happen to your function, right? Something will change. Between those points, like before -3, between -3 and 0, between 0 and 3, and so on, this will be the same function. Now let's write what kind of function. So x of t, now you want to write it as piecewise function. So t smaller than -3. What happens when t is smaller than -3? Which one of those terms is enabled?
T. For the first term.
Only this one, right? Nothing else, because this multiplies by 0, this multiplies by 0. Only this one multiplies not by 0, by 1. So it will be t. Now, t between -3 and second critical point, which is 0, what it will be? By the way, this is incorrect, of course. I'm talking about smaller than -3.
0.
It should be 0 here. Here it's t. Here it starts to be something multiplied by that one. Now, second one is larger than 0, but smaller than 3. Now what?
T squared.
No. So this one is 1. You're replacing this one with 1. This one becomes 1. And this one 1. And this one is 0.
So t minus t squared.
It will be t minus t squared. Okay? How about the next one? Larger than 1.
T minus t squared plus t minus
It will be all of them together. So it's t minus t squared plus t minus 2. basically twice t minus t squared minus 2. Now you need to plot it. You can do that with multiple different methods, but point by point or whatever method you prefer. Or you just need to know how those functions look like how to draw parabola or how to draw a straight line. The easiest way is just to find critical points for those functions and to plot them like a few points and then to interpolate between the points. Those are the easiest approaches to that thing. Let's see, so you have those critical points, 3, 0, minus 3 and 3. Those are critical points, right? So before 3, you have just 0. So nothing happens here, nothing interesting. After that, you have t. So from minus 3 to 0, we have t. How it should look like? How t looks like? T looks like that, right? So it should start where? So it's x equals to t function, right? Yeah. Just straight line. So where it starts at minus 3?
Minus 3.
Minus 3. And then it goes linearly until it reaches 0, right? So it goes like that. Then down, it goes up. Okay. Now we have t minus t squared in that interval. T squared looks like that. Something like that, parabola of some kind, right? Now you need to add them together. How they will look like? Like you need that parabola. First of all, it still starts at 0, right? So it should cross that point. Because 0 minus 0 squared is still 0. How about 1?
0.
Still will be 0 at 1. So that's divided into 3 equal intervals. This is 1, 2. So it still should be 1. How about 2? 2 minus t squared. Minus 2 squared.
Should be minus 2.
So it will be 2 minus 4, which is negative 2. Probably somewhere here. How about 3? 3 minus 9. Negative 6, so it's twice here, so it's minus negative 6. It will be here. Can you imagine how it looks like? Something like that. Goes down. Something of that kind. And that would be continuing after 3, but at 3 we have breaking point, right? We should get down to here. Now, what happens at 3? We still have the t minus t squared, but plus t minus 2, which gives us something like that. So what will be the value at that point? Point 3. So twice t is like 6, minus 9, minus 2. So what it will be?
Minus 5. So 6
minus 3, minus 5.
minus 9. It's negative 3, negative 2, minus 5. So it's somewhere here. So it should go up. And now where it will go, up or down? Yeah. It will still go down.
Yeah, minus 2.
So it will look like that. Forever. From now on. Okay. Any questions? Okay, so this is how you plot from the function. You can plot any piecewise function. Okay, let's do a few simple computations on energy. So before we go into those computations, I want to remind you something about energy, a few facts. So energy or the signal is not the same thing as energy on a resistor or any other electrical circuit. It's just abstract definition of energy. So energy is defined as integral from minus infinity to plus infinity on absolute value squared of x. Okay, this is how it's defined. So whatever x is, you just put in that interval and you get the number. Whatever the number is. If it is finite, then you get some number. If not, then you get infinity. Pay attention that it has to be positive because what is inside is always positive. So integral, which is area of positive signal, has to be positive. You basically find an area of something which is always positive. So it's also positive. Now, for real signals, you don't need to use absolute value because value squared is always positive without absolute value, right? Now, power, a little bit more tricky. You put some limit, t goes to infinity, integral from minus t to t, or to t, all the same thing basically. Now, pay attention to something very important. Energy basically takes signal from minus infinity to plus infinity and finds all the area of signal squared. Power doing the same thing, but divided by length of the interval. Then this interval goes also to infinity. Which means that obviously should be less than the energy because you're dividing by infinity essentially. So what happens if energy is less than infinity? What will be the power? Will be infinity?
Zero.
It has to be zero. Again, both of them have to be positive, but if one of them is infinity, power has to be zero. Why is that?
Because you're dividing by infinity.
Because this interval will be some number, if it's 5, whatever. And then you're dividing by 2t, and t goes to infinity. 5 divided by infinity is 0, no matter what interval you take here. This limit always will be 0. Okay. If power is not 0, what it means for energy? Has to be infinity. Another important case. What happens then to energy?
Yeah, energy infinite.
Why?
Because you're constantly adding more area. It's all positive, so it's just
Yes.
never convergent.
Look at that plot. Let's say this plot continues forever. What will be the area of
Area
this
will just
plot?
continue to increase.
It has to be infinity. Why? Because you continue in that plot forever, and the area will add on and on and on and on. Now, is that always true? Not really. So this is not always true when it's not true.
If the energy tends towards zero, you're adding stuff on, but it gets smaller and smaller.
If your signal continues to be non-zero with given height coming up and down, like periodic
Oh,
signal,
yeah, then
then this is true. But not for general function x. Because if your function, let's say it's always positive, but it goes like that. Exponentially going to zero, right? So your energy overall function, you're converging, right? So it has infinite domain, something like that maybe, but exponentially decay. Your overall energy is defined by the area under the plot. But this plot is always positive. But it's so tiny at the ends here that it's not really adding, like it's converging to constant total energy. So you might have cases where this is not always true. So pay attention to those critical cases where it looks like it should work because it's always positive and you're adding more and more area to the plot. But after all, the area converges to some specific limit, which is not infinity. Like you cannot have area higher than such and such boundary. Okay. Let's see some example. Let's say you want to compute power and energy for circuits. What is the power of that kind of signal? Hmm? No. Has to be 0, 1. Because of that, you have finite energy. Let's see why we have finite energy. It's easier to compute energy first, and then you will see why it's finite. And then you have x squared t dt. And then we need to divide that into two integrals because you have two different intervals. So it's integral from minus infinity to 0, which is critical point, of the first part, which is exponent squared. And then from 0 to infinity, because you have it only to 1, of 1 minus t squared dt. Now, from now on, it's just calculus. Right? It's not part of the course anymore. If you can compute those things, this will be the energy. Okay, so let's see. That hopefully the computation is correct. But even if not, this is the way to do it. So since you get finite energy, which is some number, the power has to be 0. Any questions? Okay, let's take another example. So here we have periodic wave, which looks like that. Some square wave. This is 1, minus 1, minus 2, 1, 2. This is some s of t. 1. So amplitude plus minus 1. And then interval of change is also 1. Square wave. You want to find again power, energy of that kind of signal. Can you guess the answer?
Energy's infinite,
Why?
because
Because when you
the
square
value
it,
is just a line,
it's just a
it's
straight
infinite
line.
area under the curve.
Yes, so you get, if you basically flipping that upside down and making it square, it will be just 1, constant 1, right? If it is constant 1, it definitely has infinite area under 1, the constant line 1 from minus infinity to plus infinity. So energy will be infinite. How about power?
Power has to be zero.
No.
Power has to be defined
Power has to be some number.
by number.
So power is essentially energy per time. So how much energy you have per time? It's 1. The only one, let's see why. Okay, so energy is obviously has to go to infinity because of that. So you have infinite domain, and it always gets you to 1, so area under 1. Clearly you can write the integral 1 squared dt, whatever. 1 squared is still 1, and then integral on 1 is infinite. Okay, now power. So power a little bit more tricky. This is limit t goes to infinity. Now, you can use that one. Or you can use even different one, a little bit easier in that case. On a single period instead of 2 periods. So we do the same thing for the periodic function. So I'm just repeating the same thing instead of doing that for those 2 periods, I'm taking just 1 period. Average will be the same. But you can compute it any way you want. Now, this thing is always 1, right? This thing is 1. So you can replace that thing by 1, and this is what you will get. What is the period here in that case? What is t, by the way? Period is 2, yes. Okay, how do you compute it now? So it will be basically, this one is 1, right? You can replace it here. Wait. 1 here. From minus t to t, or from minus t half to t half, and then you're removing the 2 here, the same thing, right? But then let's compute that integral. So it's 1 over 2t, and then t between minus t and t. So what is that? It's 1 over 2t. T minus t. It's 1. Because this is twice t divided by 2t, which is 1. Is it clear where I got that from? Yeah. So this is from computation of integral between minus t and t on 1. Right, so the answer is of course t, right? So integral of 1 equals to t. And then if you have ab, then you're taking that thing which is b minus a. And this is what you have here. Any questions? Okay, so as you see, basically all of the questions about power and energy are technical up to the point where you need to say that you don't want to compute one of them, because you can say that one of them is infinity, one of them is zero, just because the other one is not infinite, right, or zero. So just based on that and based on those rules, you can say what happens with the other one. Not always, but in most cases. You don't need to compute both of them, you save some time. But other than that, it's just putting numbers in the formula and knowing how to compute those integrals. Not much more than that. Okay, now we move to examples of periodicity of functions. Let's say we have some x of t, which is cosine squared t, minus sine squared t, plus cosine 2t. Can you say this function is periodic or not? Generally, you will have questions of that kind of things. Some strange functions, trigonometric functions blended together, and you want to say if they are periodic. Because for most non-trigonometric functions, the answer is always not periodic. You won't have that many periodic functions. Unless you have some functions, periodic function embedded in that not periodic function. So how do you know? In that case, it's very simple if you know trigonometry. Because cosine squared minus sine squared is basically cosine 2t. As simple as that. You go to trigonometric tables, which you have in formulae pages, and then you just simplify that expression to that one. And you know that this is periodic. What is a period? Yes, this is pi period. Yeah. But this is gives, right? Or you can use the formula for cosine and sine, right? I have proven that in the lectures that cosine and sine, they have specific period, which is giving us omega, which is 2 pi over t, and then we can compute t from that omega. Okay, this is for cosine and sine, the same thing. Now, for more general case, you need to do more computations. So this case is kind of simple. Any questions on that one? Yes.
So in the video, you talk about mostly relying on that fourth kind of long if conditional or whatever. And that was where if you take the ratio and it's a rational number.
Mm-hmm. So we'll get to that in a second.
But so my question is going to be, if you have like three terms in an expression,
We'll get to that in a second.
Cool.
Jeez, Connor.
I'm sorry.
Cool. I'm just so curious. I just have to know.
Yes, so basically if you have generally speaking, if you have some sort of sines plus cosines or plus sines, any combination of sine plus cosine, they are periodic if they both have pi in the multiplier here somewhere, or both don't have pi in the multiplier here. Okay? If one has multiplier pi something and another one has no multiplier pi something, they are not periodic. The same thing would be if I will put any transcendental number here. Like if I will put instead of 2, I will put e number, twice e, for example, and another one will be just 5t. They will not be periodic. Yes.
You mentioned something about it being a rational number. I mean, what if the ratio ends up being like?
Yes.
Yes.
Yes. So basically, if you have any rational number here in one of the sum parts, and another one they don't have in the other one,
Right.
then it will not be periodic. Because the ratio will not be rational function,
Like one
rational
third.
number.
Like 1/3 is rational.
1/3 is rational number.
Yeah.
Square root of 2 is not, square root of 3 is not, pi is not, e is not, and many other numbers are not. Most of the numbers actually not.
What if you have a combination of two transcendental numbers, like you have e
Excuse me?
and pi? Like one of them has e and the other one has pi.
Tough question. What will be if you have cosine et plus sine pi t? Will it be periodic? No. It will not be periodic, but the proof of that will be just because e divided by pi is not rational number. Now, will you be able to prove that e divided by pi is not rational number? This is tricky question. This is deep math, really. I mean, you just need to know that they are not. But sometimes you have irrational numbers for which division will be rational. Like square root of 2 and twice square root of 2. Both are irrational, but the ratio is 2, right? Or 1/2, which is rational. So it's not that easy to say that ratio of two irrational numbers is irrational or rational. For those two numbers, we know that this is irrational because they are also transcendental. But this is a different story, and we are not getting into those details. How you actually get them. Okay, you will not get examples of that kind, luckily. Okay, so example of sum of three things together. You want to check periodicity of that sum. Let's see. You have x of t, which is sine 2t plus pi over 8, to make it more complicated, plus cosine 4t plus sine 10t. Something like that.
It's 40 or 90?
It's 40. So first of all, we know a few things, that we can find period of this one, we can find period of this one, and we can find period of this one separately. But will they all be together still periodic?
Yes.
Yes, because we don't have any pi multipliers here. And this one doesn't matter, because if I add any constant phase shift to any of the cosine or sine, it will not change the frequency, it will not change anything to the periodicity. We just shifting the entire thing to the right or to the left, which means periodicity stays the same. The same thing happens if I will multiply it by any constants. It doesn't matter, I just scaling it up or down, right? So it will not change the periodicity of the signal. It will just stretch it that way. The same thing happens for all of those. Now, how do we know what is the periodicity of three of them together? We find the periodicity of those two first, or any pair if you choose, okay? And then we have mu signal, which is sum of those two. And then we find between those two and this one, or as many as you have, right? Now, how it works? Let's see graphically how it works. Let's try to draw that thing on the periodicity scale. So let's start with 0. We have 0 here, pi, 2 pi, let's say 3 pi, and so on. Let's use some other color. And then we have half, 1.5 pi, 2.5 pi, 3.5 pi, and so on. And also we will need smaller divisions. So it's pi or 5, 2 pi over 5, 3 pi over 5, and so on. Now, why I need all of those numbers? Because those are the periodicities of those signals. So that's what we get. What is the period of the sine of 2t? Basically the same thing like this one, right? So it's pi period. What is the periodicity of that thing? Pi half period. How about this one?
1/5.
Pi sine. So let's see how their periods change. So one is working like that, pi periodic. So it starts here, returns here, it's the same thing, right? And goes again, returns in 2 pi. Goes again, changes, goes back, and so on. Right, this is a pattern. So it gets, changes here, returns to the same point, like here, here. Right, and then again here, and then again here. Every pi repeats itself. Now, second one repeats with that period. So it gets here, 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 and so on. So what would you guess is the overall period of them together? When they both, like their sum turns to the same point, again, pi. That sum is pi periodic. Why? Because they meet at that point together. Now we add an additional one, which is that pi over 5, which is much shorter period, so it goes, jumps like that. And so on. Now, if you would compute those two together as a sum, you would get that period, right, which is pi over 2. But if you want 3 of them together, where they all meet? Pi. So this function will be pi periodic. But this is not formal solution, this is just graphical solution to explain why the answer will be pi periodic. So sum of those 3 will be pi periodic because they all meet together at pi, 2 pi, 3 pi, 4 pi, and so on. And not meeting anywhere in between together. Because this blue one actually has pi periodicity. It will prescribe everything.
But wouldn't the red and the green added together also be pi periodic? Would it be?
Green and the red will be pi half periodic, and also pi periodic, and also
But
2 pi
how
periodic.
would,
What integer goes over 5?
how would every fifth match at every half? A fifth can't match at a half, can it?
It matches here also. It meets here. You see, they both meet at the same point.
3 pi over 5 is
We're talking about this one and this one.
Yeah, but how would 3 pi,
So it's pi half periodic and pi half. They do not meet. No. They do not meet. It's just wrong. Wrong image. So this will go here and this will go, will jump above it. They will not be meeting at that point. It's incorrect. They will meet here. Okay, so let's just make a first computation here. So sine, the first one, 2t plus pi over 8, pi periodic. So t1 equals pi, Second one, cosine of 4t. Second equals 2 pi over 2. From those, you have t1 divided by t2 equals n1 divided by n2, that equals 1/2, if you like. So this one will be 2, right? Now,
It's 2, 3.
so it's 2 divided by 1. So this is rational. So we can compute T3 as N1 multiplied by T1, N2 multiplied by T1, or N1 multiplied by T2, which is the same thing, of course. So it's N2 T1, which is 5. Okay, so this is overall for those two. It's pi periodic. Now we have in third one. So you have it's pi periodic, right? And third one is sine of 10t. So t2 is pi over 5 periodic. Now t1 divided by t2 equals pi divided by pi over 5 and equals 5. So n1 equals 5, n2 equals 1, right? And then this is still belongs to Q, which is rational number. And then T3, again the same formula, n2 T1 equals 5 times pi over 5, it's 5. Or 1 times 5. The same thing, okay? Now, the most tricky question here is a little bit different. If I choose here instead of 5 and 1, I choose 10 and 2. Will it work? Obviously, I will have different answer, right? Okay, we'll choose here. This is the same pi, right? It's 10 divided by 2 instead of 5 divided by 1. All it means, I will get different thing here. I will get n2 equals 2 instead of 1. Can I do that?
Well, yeah, it's just not the fundamental period.
Yes, I can. This is just not fundamental period. So you almost never require to find fundamental period of the function. You just need to find some period of the function. When you have infinite number of possible periods, period pi, 2 pi, 3 pi, 100 pi, all of them are periods. Okay. Any questions? Thank you.